Close your eyes first, and listen to this sound. Now open your eyes and look at the image. If you have used local AI to generate videos before, you should be very familiar with that feeling. Either it was a completely silent movie, or it had a rough audio track filled with various kinds of noise. But now, things are different. AI-generated videos are finally starting to have real sound and atmosphere. In other words, it is no longer just visuals, it is starting to have a soul. LTX 2.3 has officially been released. In today's video, I will bring you a complete full tutorial, explaining everything step by step, from installation to the workflow. As of March 2026, it is one of the video generation models that can run on a local PC, combining audio and visual generation together, while also offering advantages in speed and visual quality. Hello, welcome to Smart Vision. On this channel, I keep sharing the latest AI tutorials and practical tools. All workflows, materials, and resources from this video are on my Patreon and are available to download after you register. For supporters, I provide extra professional tools and deeper guides. If you like this content, consider subscribing and supporting the channel. Now let's get started. What is LTX 2.3, and what technical improvements does it bring? LTX 2.3 is the latest audio-visual generation model released by Lightricks. It can generate synchronized video and audio at the same time, and introduces a newly trained latent space and VAE to improve visual quality. First, the visual details are sharper, and textures and edges are preserved better. This improvement comes from retraining the VAE, which allows the generated images to appear clearer. Second, the understanding of text prompts has been enhanced. LTX 2.3 expands the text encoder by 4 times, allowing the model to understand complex prompt descriptions more accurately. In other words, when you add multiple subjects, spatial relationships, or style requirements in your prompt, LTX 2.3 can understand them better and execute them more faithfully. There are also improvements in image-to-video generation. The new version reduces the freezing and frame jumping issues that were common before, making the generated motion more coherent and natural. Camera movement no longer pauses suddenly, and the visual style remains consistent. Audio synthesis is also cleaner. The new version filters noise from the training data and adds a new vocoder, making the generated audio clearer and cleaner. Random noise and unexpected sounds are significantly reduced, which is especially beneficial for scenes that rely on sound. Finally, LTX 2.3 supports native vertical video, allowing you to directly generate 1080 by 1920 vertical videos. At the same time, it can output videos up to 4K resolution and up to 20 seconds long. This means creators can produce higher quality and longer short video content. However, of course, this will place significant demands on your GPU. Overall, LTX 2.3 introduces engine-level optimizations in detail quality, motion coherence, and audio quality, making the model more stable and reliable. We need to install ComfyUI. If you have an NVIDIA GPU, search for ComfyUI on Google, open the site, and download the appropriate version. If you have an AMD GPU, download the AMD portable version of ComfyUI from the ComfyUI GitHub page. After downloading, extract it, and it will be ready to use. I'm only giving a brief demonstration here because I don't have an AMD GPU and haven't tested it myself. Also note that some ComfyUI custom nodes may not support AMD GPUs, so keep that in mind. To run this on low VRAM, we can use KJ nodes. Drag the workflow I provide directly into ComfyUI. If missing nodes appear, click Extensions, choose Not Installed, install the required nodes, and then restart ComfyUI. Note that the KJ nodes version theoretically supports PCs with 8 GB of VRAM and 16 GB of system RAM. However, it is recommended to have at least 32 GB of RAM because Windows also consumes memory. Otherwise, you may easily run into out-of-memory issues. For the workflow, we can directly use example templates that are already organized by the community, such as T2V, I2V, FL2V, and FML2V. The overall idea is quite similar. You can choose and download the ones that suit your needs. The entire workflow actually uses a 2-stage sampling structure. The first stage is responsible for generating the video content. The second stage performs upscale, which increases the resolution. Through this process, the final video can be output at the resolution we specify. In this workflow, there are two latent variables. You can think of them as two sets of raw materials used to generate the video. The first latent path is used to generate the visual frames. The second latent path is used to generate the audio content. So when looking at this workflow, you only need to remember one thing. There are two generation pipelines running at the same time. Since the workflow structure is basically the same as the previous version, and the main improvements are in the model itself, I will not go into too much detail about the workflow here. If you want to understand what each node in the official workflow does, you can check out my previous LTX 2 workflow explanation video, where I already provided a more detailed breakdown. At the same time, I have also prepared an LTX 2.3 audio-to-video workflow on Patreon. This workflow actually reuses the S2V workflow from LTX 2. If you need it, please visit my Patreon to download it and watch my previous video as a reference. Now we arrive at the most anticipated part. How well does it actually perform, and where are its limits? Instead of testing simple cases like walking or waving, I will test it using more complex scenarios. You may notice some interesting phenomena. First, let's look at audio synchronization and clarity. This test mainly focuses on three aspects: the texture of the sound, the performance of high and low frequencies, and the accuracy of audio-visual synchronization and spatial ambience. The first case is a steam engine in operation. This scene belongs to ASMR-level close-up operation. The prompt is as follows. We mainly observe two sounds: the hissing sound of steam and the bubbling sound of liquid. The key point is whether these sounds are clear and clean, and whether they are perfectly synchronized with the visual actions. Wow, very relaxing background music. It really does feel like a coffee shop atmosphere, and the steam effect is actually very impressive. But, wait a second, I wanted to hear the hissing sound of the steam and the bubbling sound of the liquid, but they're completely covered by the background music. Does this count as cheating? I tried several times and it was always like this. It seems that LTX 2.3 really insists on adding some BGM for you. The second case is a crystal glass falling onto a marble floor and shattering in slow motion. The prompt is as follows. This mainly tests material collision sound effects. We observe whether the moment the glass hits the floor produces a crisp impact sound, and whether the scattering of many glass fragments afterward has layered sound and spatial depth. Well, this one is too difficult. The glass didn't shatter, the water spilled out first, and some of the droplets even turned directly into crystals. The sound of the glass breaking is also completely out of sync. Alright, shots like this are probably still difficult to achieve for now, or maybe it just requires a few more attempts. Next is the second test, extreme detail rendering. This mainly evaluates the model's ability to represent microscopic details and complex materials. The first case is a macro shot of a chameleon's eye. The camera keeps zooming in until the tiny scale structures become visible, while the eyeball slowly rotates. The prompt goes like this. The key points here are whether the edges of the scales are sharp, and whether the reflections during the eye movement are natural. From the results, the performance is very good. The edges are sharp, and the lighting and shadow changes look correct. The second case is a fountain pen writing on parchment paper. During this process, the ink slowly seeps into the fibers of the paper, while the metallic nib produces subtle reflections under the light. The prompt goes like this. The main details to observe are the rough texture of the paper fibers and the dynamic spreading of the ink. This one looks a bit strange. How should I put it? The background music is fine, and the camera's depth of field blur is actually very well done. But the ink seems to appear out of nowhere, and it's drawing a straight line. Well, what do you think? The third test is prompt adherence. This tests whether the model can generate visuals strictly according to the instructions. The first case shows a wooden table with only 3 objects: a blue teapot on the left, a half-eaten red apple in the middle, and a yellow tulip in a glass vase on the right. At the same time, a cat walks behind the teapot but does not touch it. Here we mainly check 3 aspects: the number of objects, the colors, and the spatial positioning. Here is the prompt. This cat is very cute. Although the cat didn't touch the teapot, the AI tried to take a shortcut and simply made the vase on the far right move by itself, while the cat only touched the apple. How should I say it? In a way, that's very human-like, always trying to take a little shortcut, right? The second case shows a robot wearing a chef's hat. It is balancing on one leg, juggling 3 glowing oranges, and winking with its left eye. Here is the prompt. This scenario mainly tests whether the model can handle multiple combined actions, as well as directional instructions like, wink with the left eye. Alright, this scene didn't perform very well. The oranges are flying around like they have a mind of their own, and the robot isn't blinking. Maybe the robot in the input image simply doesn't have eyelids to blink? But the background music definitely creates that light, juggling-style atmosphere. There's no doubt about that. The final test is image-to-video generation. The focus is whether the model can preserve the characteristics of the original image while generating reasonable motion. The first case is a portrait of a Victorian-era woman. In the generated video, she gently sighs, her collar moves slightly in the breeze, and she slowly turns her head toward the camera and smiles. This is the prompt setup. Here we observe 2 things: whether the facial features change, and whether the movement of hair and clothing looks natural. The generated result is actually very good. Except that it seems the model doesn't quite know where the camera is, everything else is hard to criticize. Whether it's the background music or the sigh, they both convey the atmosphere of the scene quite well. The second case is Van Gogh's The Starry Night. In the generated video, the clouds slowly rotate, the stars gently flicker, and the cypress tree sways slightly. This is the prompt setup. This test examines whether the model can maintain the original painting style while generating natural motion. Looking at the result, it's actually very impressive. It successfully generated natural motion, and it made me feel like I entered this drunken world just like Van Gogh, and peacefully fell asleep. And that background music, it does feel a bit depressing, but it fits the mood. But it's the weekend, we shouldn't feel depressed. We should be happy. So, what do you think? Alright, the testing is finished. Overall, LTX 2.3 is very impressive, and it might currently be the best local AI video generator available. It's also very fast. A 10-second video can be generated in about 1 minute, which is extremely efficient. The only thing worth noting is that it's quite difficult to generate completely quiet scenes. I'm not sure whether that's because of how I wrote the prompts or because of the training data, but it really likes to add background music. Aside from that, the video quality itself is excellent. Okay, that's it for today's episode. This is Smart Vision. If you found this video helpful or interesting, please remember to like and subscribe. Your support is the biggest motivation for me to keep creating. I'll see you next time.